Hello and welcome back. And so next up, we've got Anna Henningsen. So Anna is one of the most active contributors to Node.js Core over the last 4 years. She is fueled by a passion for Node.js and its community, and she's recently become a part of the MongoDB developer tools team. Um, she's been active using Node since about 2012, which I can't believe because she certainly doesn't look old enough. And she is my hero. I've seen her do more successful live code demos at conferences than any other speaker. I did find a little quote from her online in the past where she did say, "The most fun talks I've ever given are about live coding and implementing features in Node.js." So I suppose that makes good sense. Anyway, all the way from Dusseldorf in Germany, please give a warm welcome to Anna Henningsen and Node.js and the struggles of being an event target.
Okay, hi everyone. So first of all, no live coding today. Sorry. Um, I I'm Anna. I'm a software engineer at MongoDB. Joined the company in September, so that's all still pretty fresh. And I'm not going to be talking about any MongoDB stuff. You'll see my Twitter handle at the bottom here. I posted the links to the slide for this talk there as well. And yeah, so let's get started. So if you look at these things you recognize in a lot of these names probably, but what do they all have in common? You can tell that most of these are things that seem familiar because they are global variables in the browser or Node.js. And in fact, it's all web APIs that Node.js adopted at some point in its life. And that is a move that Node has been making towards using more web APIs. And in fact, a lot of these are still pretty fresh. I highlighted the ones that are just from this year. So it's all moving fast towards technology. And one thing that I want to look at in particular here is EventTarget, because it's kind of a fundamental building block of web APIs. So for example, abort control and MessagePort, they are EventTarget instances. So like they use that API to build and extend it. So yeah, why did Node not have that in the first place? Let's look at how the two of them differ. So there's EventTarget, there's EventEmitter, and you can use them in very similar ways. So something that is called add event listener in the browser is called .on in Node.js. Dispatch event is called emit, but in the end they kind of do the same things, and it's like very similar APIs that perform very similar use cases. So you use add event listener or on to register a function with this object and use .dispatch event or .emit to call that function. It's basically a way of splitting up the call side of a function from where that function is defined. In the web, you can use one additional way of registering this listener, which is this fake property kind of thing. So you can use .on clicked instead of .add event listener click. Sometimes that's a bit more convenient. It won't fit every use case, but you can do that. Let's look at like why we have this distinction. When event emitter was added in the first place, that was like June of 2009. Node was very young at that time, and there had only been 2 contributors, one other person besides Ryan Dahl at that time. And things were just added in a very ad hoc fashion. So it was not necessarily even a goal to add something that would be browser compatible at some point, just something that worked. And there are some technical reasons to not use EventTarget in Node.js as well. There are some browser concepts that just don't apply to Node.js. If you click on an element of a web page, that's kind of also a click on the surrounding element, and it's also a click on the whole page. But in Node.js, you don't have that kind of thing where something bubbles up a tree. Just isn't there. So there are some differences between what the browser needs, what Node.js needs. And what ended up happening is that we came up with something that is kind of like EventTarget, but not quite. And that's never a great situation to be in. Having 2 APIs that perform similar functionalities, but look slightly different. Right. let's take a step back. As you may know, we added workers to Node.js. As you may or may not know, workers use message ports for communication internally. So this is a web API, the MessagePort one that we try to follow as closely as possible. Workers were introduced in Node 10, but in the browser, MessagePort is a subclass of EventTarget. Event was added this year, if you remember. So it was we added it in Node 14.7 and started exposing it to users in Node 15. And that, if you think about it for a second, that's kind of weird. How did we end up using an API that was not there in the source code? Well, the answer is that we didn't. What we did, or more precisely what I did, which I am not feeling great about, but I also wouldn't know why I did it. So what you could previously do with message ports in the past in Node.js, you could use event emitter style listening and some of the web style listening. So you could use .on with a message argument and a listener, and .on message as you would have in the browser. But you would not have the full EventTarget API available, which is unfortunate. But at the same time, so I did in the past not want to make workers support a Node dependent on adding EventTarget. Because when you do add a feature like that to Node.js, there's going to be a huge discussion every time about how we do it, how we expose it. And I wanted to get workers done. So that is kind of like how we ended up in this situation. Well, it would be nicer if we could also use it in a fully compatible way, where we use EventTarget. And this talk is basically the story of how we got to that point. What we changed in Node 14.7 was previously MessagePort inherited from EventEmitter and kind of also inherited from this other thing. I'll go into a bit more detail on that in a second. But the important thing is it inherited from EventEmitter, and what we then changed is we made it inherit from like an internal Node class that is kind of like a utility. It's called Node EventTarget, which inherits from a proper EventTarget class, but it also provides hooks that are very similar to the ones that provided by EventEmitter, so that you could essentially keep using message ports the way you used them before. That was kind of important to us because we wanted to like have compatibility after we released it in a minor release of Node.js, not the super major one where breaking changes would be expected. Well, one thing about that, so obviously this changes the inheritance hierarchy. It's previously message ports were instance of EventEmitter, now they're not anymore. And now they're instance of EventTarget. And we were kind of like, or I was kind of like, well, this is okay because people are not really used to checking instance of something. They're used to using the methods on the object that they can use. That is the important bit. So after I finished the slides for this talk, just last week, somebody opened it with this title. Parent part extends EventTarget in Node 14, but extends EventEmitter in Node 12. Turns out we did break it in some ways that were not quite expected. And you can look at this issue in more detail if you want. But basically, we did not port over a .emit function from EventEmitters to this internal Node EventTarget class because we didn't expect people to use it. Because why would you emit custom events on a message port? Sure, you could, but why? Well, there was some misunderstanding about how .emit error works on a message port. And this change that we made exposed that misunderstanding. It's not really a bug on our side, but it's still unintended breakage. So we're in the process of fixing that right now. But anyway, so going a bit more into detail on that, multiple inheritance is kind of a weird thing to do in JavaScript. So in JavaScript, you can only have one superclass for each class, or one class that an object inherits from. In the case of MessagePort, so MessagePort are transferable objects. What that means is that you can use a MessagePort to transfer a MessagePort to another thread or whatever is on the receiving side of that channel. They're not the only examples. For example, by now you can also transfer file handles and array buffers. So you can move objects from one thread to another, for example. In order to make that happen, the V8 API that we use for serialization and deserialization in .post message, that requires these objects to be implemented in C++. Well, when we added EventTarget, we added it as a JavaScript class, as an ES6 class to our source code. And that's kind of tricky because C++ classes cannot inherit from JavaScript classes easily due to the way that V8 models native C++ backed classes. So what did we do? Okay, apparently there's some kind of message that I'm not seeing that should be hidden. I don't know. I'm sorry. Yeah, really not sure. Anyway, I'll just go on with the talk. So yeah, how do we solve this? So there's an obvious brute force solution to this problem, which is if we want to inherit from EventTarget and it cannot be a JavaScript class, we could implement it in C++. That's what browsers do, and they are just fine with that. But well, I also heard somebody say a couple of weeks back that browsers are kind of like C++ engineer employment programs, and Node.js is not. We want accessible and maintainable and fast source code. And to the vast majority of Node.js users, C++ is not a very accessible or maintainable language. And fast point is more. So when you have calls between C++ and JavaScript where you jump back and forth, it gets kind of expensive. We did not want that overhead. So what's the alternative? We can look at how we did this before, because if you remember, MessagePort inherited from event emitter. So what you can do with old style classes, like from before ES6, when you started using the class keyword in JavaScript, what you could do is you could essentially take an object and turn it into an instance of a class. It's not something that you would usually do, but if you need to, it works. So you can create any object, use eventemitter.call to make it, like, take the constructor and call it on an object and just let it pretend that this is not already an event emitter. And you set up the prototype change so that all the methods are there, so that .on, .emit is there, and so on. And then you can actually use those methods. So this example actually runs. This is what we did previously. Turns out this is not that easy to do in this case. So EventTarget, we implemented that as an ES6 class. And calling that as a function is not allowed. So this would not work. The EventTarget.call would just throw an exception, and it's not going to work. But we can still kind of follow the same approach. Oh, right. There's a talk tomorrow by Thomas Watson about JavaScript prototypes behind the scenes. If this is interesting to you, that talk is probably going to be interesting to you as well. But yeah, anyway, we can kind of take that same approach. This is actual excerpts from the Node.js source code. What we essentially did do is we took the event target constructor, we put all of the source code that was inside it into a separate function called init event target, and then that function we could call a new object. So for example, for message ports, we set the prototype change so that it looks as if there was a ES6 class message port in extends node event target kind of thing, even though it isn't really there. And we use this onInit function that is called from inside the C++ message ports constructor. And it calls this init function that sets up all the state that should be there. And there's also a to-do in that function that if you're interested in working on this kind of thing, feel free to ping me about that. Yeah, so this is how we solve that problem. Then If you remember from the earlier slides, the way that I can actually show this. Right. So the way that you access data from event listeners in the web style API, you get an event object. If Node.js event emitters, you just pass in some arguments to emit, and the listener gets those arguments as arguments. In the web, you always have this event class, and you only can pass events as arguments. That turns out to come with some performance implications. So when I first opened a pull request that did this, that moved MessagePort from EventTarget to from event emitter to EventTarget, there was like a 50 to 75 performance drop when we ran the benchmarks on that. That's not good. I mean, that's 4 times slower than it was before, which you don't really want that. What do we do in that case? So what we did end up doing, is we profiled the benchmark that we ran. So in this particular case, we generated a flame graph. I'm not a graphic designer. I just took a red toned issue with white background and inverted it so that it fits into the dark theme of this dog. I don't know, the colors might seem a bit weird, but that's not the main point here. The point is that in this thing, you can see that the event constructor of this event class that gets passed to the listeners, that takes a really long time. So like it looks like it's almost 50% of the entire benchmark runtime, just this constructor. And so there are 2 things that stand out if you look at this in detail. One is there are these 7 peaks to the left that all kind of look similar. And when you look at what the stack traces actually say there, what's happening is that you can see it's setting private properties. And you can actually count the number of private properties that event instances have. And that just is not optimized in V8 yet, or at least it wasn't at the time when we added this. That's just the way that JavaScript features work. They are not optimized in the beginning. They are added so that they work, that they conform to the specification, but they're not fast in the beginning. So that was one thing. The other thing is like this big chunk, which is essentially just an object.defined property call that was also very slow, that we did not want to do this way. So how do we solve these things? So for the private properties one, that's easy. We didn't stop using private properties, started using symbol properties instead, which is basically almost close enough to what we want. Right. So that we did. This is not actually part of the PR that I opened. This happened because something else that we did ran it private properties well, for not performance reasons, but still. So anyway, this already solved a lot. If we do this and get rid of that object.defined property call, we actually speed things up a lot. We only have 20% performance impact left if we do that. So like a relative plus 75% improvement on the benchmarks. But let's look at that object.defined property call in more detail. Oh, one thing before. So I have an opinion about private properties. This is not my current employer's, not my former employer's opinion, not anybody on the Node.js team, obviously not TC39's, not the conference's opinion. I would not use private properties. Not because of performance reasons. I mean, at some point, JavaScript engines are going to optimize them. That's not a question, but I don't think they fit very well into the model of how JavaScript objects are supposed to look like in the thought model that you're supposed to have of them. So if you don't like them either, feel free to not use them. If you do like them, okay. It's not like I could stop you. But sorry for the jump. Let's look at this object.define property call. So there's this isTrusted property on event instances that is, according to the spec, an own property and a non-writable, non-configurable one. And that is kind of unusual. What it essentially leads to is the fact that this property cannot be overwritten in any way. Like you cannot change on the itself, and modifying it anywhere in the prototype chain won't get you anywhere. This is unusual. You don't usually do this. And it turned out that this was really slow, as you saw. And I mean, there were ways to get around this. We could have moved it to the prototype or something and have it be forgeable. But the name isTrusted, and the fact that it's spec'd this way kind of made it seem like there were security implications to doing so. So we decided not to do that. If somebody wants to come talk to me and tell me what the exact security implementations of isTrusted are, feel free to do that. I did not find a lot of information on that. But anyway, so I was kind of stumped. How do we progress from this? How do we make this faster? There's a good solution for that, especially if you're me, which is you go to Twitter and you ask people that, partially people on the V8 team, because that is where this is implemented. And that actually helped. So Tone, who's on the V8 team at Google, he basically gave this advice that there's this trick. So in the previous code, we always created a new get function, but if we don't do that, it's going to be faster. We did that. We moved this isTrusted getter out of the class, changed it so that it will always be the same function and not a new one every time, even though the source code will be the same. And it was like a 200% performance improvement on the EventTarget benchmarks. So like 3 times as fast, which was nice and surprising. I learned something that day. But yeah, so where does this get us? In the end, we still had 30% slowdown. That's probably not okay for Node.js feature to slow down that much in a Semver minor release. And in the end, that's because event instances are just not plain JavaScript objects. They have custom properties. They have their class instance. They're just not free to create. And another thing that I learned over time while working on Node.js from the V8 engine is that sometimes it makes sense to have a fast path and a slow path. And the fast path can be fast, and if people start using something that triggers the slow path, then they just have to live with that. It's kind of what we did. So if nobody actually uses the EventTarget style listeners, we don't need to create event objects. We can create them on demand once there are such listeners. That is the approach that we eventually took. And in the end, so the event emitter style benchmarks did not show significant performance regression after that. And if you look at the difference between them, if you use the EventTarget style API, you get like a 30% slowdown in the end. So originally we started out with a 75% slowdown. Then we tried to optimize it. And in the end, we had a 30% slowdown that was still remaining, not quite as bad. But it was fine because this only affects people who use the new style API, the event one that was added in that release. So on a final note, people don't really care about performance as much as they think they do. They don't care about fast APIs. They're just happy to see like these numbers. If something is like plus 200% faster, that's always yay. But whether that actually affects the performance of their application as a whole, probably not. So Node.js is not always good about seeing that as a big picture. If we had started out with MessagePort as an EventTarget style API that was as slow as my original port would have been, everything would have been fine. Nobody would have complained. People just don't want things to get slower, which is fair, but yeah. So yeah, MessagePort is an EventTarget since Node 14. We added several EventTarget related globals in Node 15. There are links to the relevant PRs in the slides. This talk is mostly based on a blog post that I wrote a while ago with some current updates, but still. If you want to read about this instead of listening to me talk, that's also a good resource. If you want to ping me about the to-do that I showed a while ago in the slides, feel free to ping me on Twitter or something. And I have uploaded the slides and posted a link on Twitter. And that's it. Thanks for listening. I hope you enjoy the conference.
Thank you, Anna. Thank you ever so much. That was amazing. I've just been told that I'm afraid we don't have time for questions for Anna, but if you have any questions, you respond on to pretty well, and so talk to Anna through Twitter.